let's get this recording so anyone who misses this can catch up later. So, and I have an update. See, I told you guys, I'm really unprepared today. This is not bug fixing, today is terrain geometry division. Alright, I'm gonna finish chewing and then explain what the heck I'm gonna do today. Skittles are good, but not when you intend on talking. So the idea of today is that I've got, here, I'll even bring up the game and kind of make my point in person, or not in person, with the game running. So first off, I finished, probably much to a lot of your chagrin, I finished the woodcutting code off stream. It took me about half an hour to rewrite it from scratch because I was doing something incredibly stupid. And I figured that out far too late. So, I'll just put this down and show off what I've got done. And that's these guys being able to kind of cut down trees to their heart's content. So it was a much... Anyone who was watching before, the old solution was essentially... I tried to make a separate data structure that held bundles of trees. And that really wasn't working out because a lot of the data was redundant. So I had the pointer to the tree that lived in the actual game world, because remember, the game world represents everything by a giant node tree based off of a root node. So before it was, all the trees lived off of that root node. And then I had a different data structure that was pointing to every single tree separately. But that was, as it turns out, like the dumbest solution I could have come up with. Because the moment you delete a tree off of the game world, you then have to clean it up also in the separate data structure. So I would have had something scanning the bundles of trees every frame, and then updating those as trees were cut down and deleted. The new method's a lot cleaner. I realized that the data I needed already existed, and I just had to organize it correctly. So now, every cell has a group node that is a node that has no renderable object attached to it. It exists only for the purpose of grouping other nodes together. And then as a subnode, there is every tree that exists in that cell. For example, this little clump of trees here exists in a group node that's centered on this node, and that gives it not only a small relative position, but it also gives us a little better idea of how to quickly throw away trees that are far away. So before I kind of had to do some extra processing to figure out what was the closest group of trees, and all of that was becoming a little too much. So what I do now is I scan each cell first to find out who the closest cell is, and then I say, okay, this one is the closest cell that also contains trees, so now let's find the closest tree in that cell, and from there, it's actually pretty easy. So, old task done, right? I've already got it marked off in the Trello. I think I do. Do I? Yeah, right? Yeah, fix woodcutting job. It's on the done list. And that, it's just kind of crazy that, whoops, hello, you shouldn't be getting called. Oh, no, it can. Never mind. I just realized what was going on there. Sorry, random breakpoint left behind from previous debugging session. Didn't mean to leave that there. So, that is fixed. And yes, Yash, those little dudes are billboarded. They are simply, for now, just little sprites. I'll upgrade them maybe. I don't know. I might even just keep them as 3D models. I kind of like them as 3D models. So, today, the big problem is all the terrain is one giant kind of amalgamation of polygons. When I say draw, it then proceeds to draw the entire terrain in one go, which is good for some things. For example, it's great for performance because you're sending all of the vertices and all of the normals and all of the geometry data all at once. But it's also bad because if I want to do something like a fog of war or some kind of line of sight system, then obviously there's no easy way to hide certain vertices if this is one giant node. So we need to actually break terrain into not only the cells, but figure out a clever way for the skirts to also be a part of that. So, that's kind of what I have planned for today. And no, Yash, they don't actually ever turn around. Right now, it's simply just a billboarded effect that is just a set of animated texture coordinates more than anything else. So, flipping them around is unfortunately not as easy as I would like it to be. I need to honestly just jump into my effect code and just add something that allows me to flip them. But for now, the billboarded stuff is working well enough. And I'm trying to get gameplay in before I worry too much about my graphics. I just wanted something that was something that held up and communicated the basics of what I needed. So little people walking and standing and sleeping, right? Fairly simple. So billboarded quads kind of works for me in that case. So let's dive in. So the first thing to do is obviously to somehow, well, not to somehow, to find the spot where these are getting generated, and instead of generating them into one gargantuan mesh, to generate them in a bunch of little ones, and not even worry about the skirts until we actually have to figure out what the visibility should work like. Because the problem is, skirts technically belong to two polygons, right? This polygon here and this polygon here have this skirt in common. So if one of them is visible, technically we would want this to be visible in some way. The problem is we don't want, if you enable one and disable the other, we don't want the one that's disabled saying, this shouldn't be visible. Right? We need to figure out a smart control mechanism for these things. So, I'm actually going to jump all the way over to the terrain generation and the world generation, because it's somewhere between these two files that I know the geometry is getting generated. Question is where? Luckily, I've made, or I shouldn't say my partner made a mesh generator class to kind of make generating generic sets of vertices and normals easier. So at this point, it's fairly simple to just hunt down where we use that code. Also, we have a file that is needlessly including it. It's always nice to keep your pound include. I can't talk. It is always better to keep your pound includes clean, because that lowers your compilation time. As smart as compilers are, they are still really dumb sometimes, and so removing unnecessary includes will save you a lot of time at the compile step. Which might not seem like a lot, right? Like, there, I just recompiled the game. But if you have to rebuild everything from scratch, you want as few dependencies as possible. So, here's our vertices. We're kind of generating, so we tell a cell to generate its own mesh. And you can see here, here's the mesh, it allocates the space. Ooh, we need to double check that that's getting deallocated somewhere. I just realized. Because this, yeah, this calls new all over the place. And I don't recall there being... Okay, here's some matching deletes. But we have to remember to call clear at the end. And what's frightening is, here it is, but we're not calling clear. Unless, okay, the destructor calls clear. Okay. A little worry there, but as it turns out, it's fine. Okay. So here we are generating all our vertex data, everything from colors to... I'm very curious what some of this code does, honestly. I have no idea. Well, no. I can make educated guesses. But the big thing here is all this information is getting generated, but we want to make sure that it doesn't get lumped together the way it was before. So the question becomes, who is calling generate mesh? Ah, and we're back out in our world generator. Okay, so here we've already generated all the terrain here. And what we do is we create a list of geometry objects and assign a single vertex coloring shader to all of them at once. So this kind of keeps us from having a lot of different materials flying around. It also simplifies our job of wondering what shader is on what tile. We just kind of load in this vertex coloring material object and then just apply it to the whole thing. And then here's our biome color palettes that we worked on. That might have been the first or second stream I ever did, was biome color palettes. It was really early on. Granted, I think I'm on number 7, number 8 at this point. Granted, I haven't been recording them either, so I'm kind of flip-flopping back and forth. But not the end of the world. So where do we split this up? That is the really defining question here. Because it's easier for us to kind of slap them all together into one. It's a little more difficult to split them up. Even more difficult to do it somewhat smartly. Because if we do this code correctly, right, you shouldn't see any difference. So if I do this right, I won't know. Which is kind of scary and kind of good. A lot of good programming, you know, is good because you don't think about it or you don't really realize it's there until you go digging. So we go through every single cell and we set that color palette. Okay. It's been long enough since I've written this code that I kind of have to re-engage myself with some of it and recall what the heck was I doing way back when. Okay, so this cell geometry list, we only want to be one cell at a time. And then we just want to generate a ton of generic geometry objects. So this somehow needs to move inside of this for loop, as does this. Also, we want our various memory clearing agents inside as well. So this might work, because we're generating a new geometry list. We are then appending the only cell to it. And then after we append just that single cell, we add the material, we create a new geometry object, we add it to the root of the world, and then we proceed to clear its data afterwards. Now the one thing this is going to do is it should pile everything on that epicenter at 0, 0. Or at least that's what I think it should do. I actually don't know. The data might actually get dropped into the right place. Okay, it is. Interesting. So that's somewhat expected and somewhat unexpected. It's expected because we're generating a bunch of vertices that are all over the place. So when you generate an entire field of vertices, they are going to have positions that are not relative to an origin, but are just relative to the space in which you're generating those vertices. So I just have a 2D plane, and I'm saying create all these vertices, and then create polygons out of them. The game is then going in and saying, okay, for each one of these, we're just going to put them where they are, even though if you look at the origin of that node, it is going to be 0, 0, 0. And that's not exactly something we want. We need to go in and do that slight little tweak to our mesh to make sure that this works out the way we want it to. Because the other thing I'd like to do is have a cell be able to actually own things. So when, for instance, those tree bundles I was working on before would normally say, oh, I need to be, attached to this node, or I need to be, a person walking along terrain should say, I need to be able to identify that I am near this node, therefore I am in this zone. It gives us a little better control over the logistics of where things are, and eventually it'll give us better control of where they're going as well. So when they try and walk from one node to another, we'll be able to say, what's the height difference? Can you actually walk up that cliff or, down that cliff safely? Or are we going to say, no, you have to walk around? So, okay, we're generating everything where we expect it to be, but we have to do a little tweaking. So this generate mesh function is where we might want to do that tweaking, because it's actually getting all of its vertices from, where is it getting? Okay, so the owning graph is creating all these vertices. So there's two ways we can do this. We can continue to do this the way it currently is done, where the node is sitting at 0, 0, 0, right? Dead center of the world. And then the vertices will live a random distance away from that node. And that's kind of the current method we have. We have that method mostly by accident, but it's a happy accident because at least it looks right for now. The downside is that if we try and do anything that says, well, what's the relationship between these two cells? Right now, the engine doesn't think there's any difference. It thinks they're all piled on top of one another at that origin. And that's not exactly something we want. I'm kind of afraid that the engine's going to try and do something cutesy, and we don't really like the engine doing cutesy things if our data doesn't match what the engine thinks the data should be. Mirror's Edge has some music I don't recall, actually. I'm listening to this and kind of... I don't remember this segment specifically. I don't know. Whatever. Put more things in my mouth to shut me up so I can get a little work done here. So we need to essentially give it an offset so that the vertices are in the right place, and then we need to move it back out again. It might seem a little counterintuitive. It might seem like we're doing a lot of extra work for no reason, but I promise it is good, valid work that does need to get done eventually. So I think, yeah, we're only really calling this generate mesh in one place. So I'm thinking we should just be able to modify this one function and be fine. The question is, how do we want to do this? Okay, so first things first, we need to grab our origin, right? Without our own origin, all of this data is completely meaningless. So before we even go so far as to modify anything else, because we need to get our data before this point. So let's just grab our origin nice and early. Oh, okay. So we already have a 2D origin. We just need to upgrade it to a 3D origin. Because remember, the engine doesn't care that our current terrain is broken up into one 2D plane, and then we later do all the elevation changes. It gives no shits. So we need to actually include that bit of 3D information right now, so that later on... Actually... we might be able to do without all of that right there, and all we would do is just say, well, everything's relative to your origin. Now this will definitely break where everything is. Now we'll see all of our tiles get piled up pretty much on top of each other like this. So you can see that the skirts here have survived, but all the polygons otherwise are in one giant pile here on top of each other, and some of them are actually even still able to reach out to the endpoints. Interesting. But for the most part, if you look at this, you can actually see pretty much every single tile is here somewhere. It's somewhere in that pile. I'm a little curious and frightened about how all the rest of these polygons are kind of reaching out into what I can only assume is an infinity, or pretty darn close to that. I mean, I'm just like scrolling and following this terrain heading in the north direction, and it's just kind of going. Alright, well, whatever. We'll keep going. Hi, Giacomo. I'm glad a number of people were able to join me on such short notice. I kind of looked at this task and just went, well, this should be nice and fast and easy, and something that I can kind of get away with actually streaming. Whether it turns out I'll actually be able to get this done, we'll see. But it seems to be going well enough so far. It seems to at least be going as expected. We'll see if that continues throughout the entire thing. Okay, so we've got... Yeah. So I'm going to actually nuke the elevation here, because we're going to move everything later to their right elevation. So we're essentially taking every single polygon now and dumping it on that 0, 0, 0 origin at the dead center of the world. What is going on here? Okay. Here are all the skirts. I'm going to turn skirts off for now, just because that's going to be a little mind-boggling until we get it all in place. Oh my. So here's here is every single polygon lumped on top of each other at that origin. And you can see they're all Z-fighting. And that's fine. We'll break them up later. But that's actually really cool looking. I don't know if you guys can see the banding quite as well as I can. Yeah, you can. That's... wow. Yeah, that's cool looking. Anyway, I need to stop breaking things and start fixing stuff. So, our new cell geometry is a node. So it has, of course, our standard set node position. And we're just going to give it... let's see here. Cell array. Okay, so we actually... I don't know why I keep doing this. I keep finding places, though, where any given cell, I seem to dereference everything like 5 times, which is really bad. You'll notice I dereference it here So this is two dereferences, right? You got the dereference to actually go from cell graph to cell point instance. And then you have the dereference when you go from pointer to object. And then you've also got the array addition here. So it's just kind of, there's a lot of crazy stuff going on in here right now that I'm doing multiple times unnecessarily. And it's a lot easier if I just do it once. And I don't know why I continue to make things difficult for myself, but I do. Because what's life if you don't make it a little difficult for yourself sometimes, right? Alright, those look like the only two places I was actually doing that. Oh well. But I'm going to do it in a third place and grab my origin, and then I'm also going to grab the elevation. So now we're doing that kind of artificial node movement and pushing them back out to where they should be. There we go. So we still don't have the skirts turned back on, but that's fine. The skirts can be fixed easily enough. The question is how we want to actually arrange the skirts, because the problem right now is that, as I said earlier, the skirts have kind of two owners, and we want to make sure that the right owner is getting control over that skirt. And this is kind of where the impromptu-ness of this stream kind of shoots me in the foot. I've done the easy task, great. I now have a fair bit of work left, and I haven't actually thought completely through how I want to get this done. I actually kind of like the terrain like this without the skirts. It looks really friggin' neat. Granted, it also causes the shadows to kind of wig out in a million different ways, but it's still kind of cool looking. Also, this is somewhat worrying. I've obviously created a map and not equally spread the cells out among this graph. And it's a little worrying. I need to come up with a better way to do it, because you can see, like, here's a cell whose area is so large that, yeah, it has trees on it, but the trees are so few and far between it doesn't match the rest of the area. And yeah, Timozy, the Verneuil cells are kind of obvious in this state. In fact, they're kind of obvious most of the time, unfortunately. But we'll work on that eventually and clear that up a little bit, so maybe they're not so apparent in the future. Okay, so let's get the rest of this fixed up so that we can actually have nice things again. So this is kind of the more difficult one, right? This is, I won't call it problematic. It's just something I haven't thought a ton about. Now, we could turn them back on and leave it the way we had them before. Not exactly a big fan of that, though. Also, it looks like each cell is generating all of its side surfaces, which means that everybody is going to have their own set of skirts, which actually might work in my favor, despite the fact that it was poor programming before. Let's just try it. Why not? Oh, okay, no. My partner was smart here. Hack to make the mesh generator discard these vertices and edges if the cell's edge is below another. So what he's saying is everybody is creating the skirts of what is above them, right? Let's see. Hack to make the mesh generator discard these verts and edge if the cell's edge is below another. So as a cell, I own all the skirts that are headed downwards, but not the ones that go upwards. Yeah. I mean, he calls it a hack, but it's a simple if statement that does what we need it to do. So it's honestly fine. I shouldn't keep commenting all this out. This needs to be commented in at some point. And what's funny is, we're calculating and inserting UVs as if it matters. As if there's like some kind of UV map going on here. There really isn't. And I'm kind of curious. We're generating tangents as well. But you'd think that the engine should be able to do this, and that we shouldn't have to. It seems almost counterintuitive a little bit that we're generating those tangents. Granted, he got the code working, so what am I to complain? Okay. So this is a little more difficult, because you can see he's modifying the vertice array in multiple places. And it's not just in a way that generates extra vertices, but also he's doing a lot of work to ensure that we don't double up on geometry as well, which is fine. But at the same time, and yeah, Chakma, I do need to add a minimum distance between trees. The problem is right now, it's using a random point generator, and the random point generator doesn't have any history. So it has no idea where it's previously placed trees, and short of scanning all the trees in the same polygon and then ensuring that the trees aren't too close, there's not really a simple way to do that and keep it random. Granted, it probably shouldn't be a completely random generation in the end. Procedural generation isn't actually random, it's just kind of a smarter random. But I still need to do a little work to get them a little more spread out, because yeah, right now we have trees sitting on trees, and part of me kind of wonders if my random point in triangle function is working correctly. I'll probably look at that eventually, but I thought I wrote it right. It seemed right. I don't know. It seems to also be generating a lot of trees along edges, which is not frightening so much as unexpected. Random number generator shouldn't be generating things like, trying to find a good clump, but like these right here. These are all sitting on one edge. Or maybe they're not. Also, it's kind of funny to see that despite having my, despite having all the skirts uncommented, because of the movement, the skirts are now kind of floating randomly throughout the levels, and I need to fix it. It's just kind of funny to see them, like, hiding under geometry and floating over the landscape. Man, maybe I should do floating islands. I'm not gonna do floating islands. Sorry. It does sound fun, but not for this game. Okay. Enough jibber jabber. Time to actually get something here. So it grabs the edge. And this edge, okay, so here's the cell on one side, and then so the cell on one side is this pointer, and the cell on the other side is the other cell pointer, or not pointer, that's just an instance. I'm a little worried that this here and this here are doing giant copy constructors, but I'm also not too worried because it's inside level generation, and because it's inside level generation, I can kind of do without. So, I think the easiest and quickest way to just make it look nice again while I think about this is to just do this. And we want this to be 0, because every time we use elevation, we're essentially doubling the height, because we're also adding the elevation in the node positioning. So there's no reason for us to be doing this twice. And I'm subtracting out the elevation here, because once again, otherwise we'd be doubling that height, and that'd be way, way too much. Let's see, is there any other crazy spots where I'm doing anything I shouldn't be? No, that looks correct. Of course, looks have been deceiving before. I've said, yeah, that looks fine, and then run the code and been horrified when things don't work as expected. Okay, let's try it. Worst comes to worst, science. Hey, okay, so it's back to how it was. So now this is where we get to do kind of the more interesting stuff. And actually, before I dive into the more interesting stuff, I'm actually going to just commit what I've done for prosperity's sake more than anything else. If I do something that completely breaks everything, I can at least jump back to this kind of checkpoint. So let's see, we split cells. I guess we split the terrain geometry into cells, or into nodes based on cells. There we go. And made all vertices relative to cell, and adjusted node position to compensate. There we go. This should be nice and clear if compensate vertices. Really? Vertices should be in my dictionary of words that this computer knows. Okay, so we removed an unnecessary dependency, and then we shifted things around. There's really not a bunch of code creation here, it's just mostly moving, honestly, and that's fine. We don't want to generate a ton of new code every time we want to modify or tweak things. Okay, and these are some nice little changes inside one function. So this shouldn't really... I can't imagine this breaking anything outside of its set. Alright, so now is where we get a little freaky. So we're going to take our cell geometry, and we are going to disable them. So this should hide all the world geometry first. And I'm kind of starting to edge into that territory of having a fog of war that works. So, and you can see it worked, like, there's nobody here. And now it's really apparent when I have giant chunks and lines of trees. What the heck was that? Oh. Oh my gosh. I had such a freak out moment. Oh, that was glorious. So they're cutting down trees, and without valid geometry to hold them in place, as they cut down the trees fall into forever. Into this kind of black hole that I'm calling space, right? Oh my gosh. I just had a moment of pure horror as I see white things start dropping down. I was wondering if it was the people falling, or if it was the trees dropping all over the place. No. I'm good. Whew, just a deep breath. Everything will be okay. It's just funny to watch them keep cutting them down, and a tree every once in a while drops. And so the one thing you will notice is that without the terrain, you can't put down buildings. You can't click on anything. There is no picking that will save us in the world right now. So, maybe disabling them is not the way to go. At least not completely. We might be on the right track. But making... Okay. Cell geometry is a kind of geometry. So I'm going to assume it's going to have a geometry object that I can set the geometry... Yeah, I can set the flags. There we go. And I don't actually know what the geometry flags look like. Set geometry flags. So I'm going to look in the docs. And let's get this so it's not eating my whole screen. So the flags... Invisible. That's what we want. We want it just to be invisible. And so we're going to get a little cute because I don't want just to set one flag, right? We don't want it to just say that it's invisible. We want it to continue to do things like cast shadows, and we also want it to be able to have other effects attached to it. So what we're going to do is we are going to say cell geometry get object, and we're going to set the flags to the current flags, and we are going to and it against a knotted flag. That one. Or I'm sorry, no, we don't want to remove a flag, we want to add a flag. We are going to OR the flag onto it. So flags are integers in C++. They aren't really flags in the same way that C# deals with them. So because it's an integer, what we can do is we can take the current flags that are attached to it, and we don't really have to care what they are. And what we can do is we can just use a standard Boolean OR operator, or sorry, not Boolean, just a standard OR operator, and we are going to OR our new flag with the older one, with the old set of flags. So this will make the new geometry invisible, and hopefully we won't see all the trees falling through into Never Never Land. There we go, much better. So this is nice too because it keeps our collision on. You can kind of see the house turning on when we're in valid space, but because we can't really see what's valid, it's not really easy for me to find a valid spot for them to build a kind of place like that. But still, it accomplishes what we want it to. So now... Okay, we've turned all of them invisible. We now need to do the opposite to ones that a person has been in. So, we create a town center. Where do we create the people, though? Okay, we're not going to create the people in build terrain, I can tell you that. I'm probably creating them in the game world itself. And here they are. Here's our 10 people that we are adding to the world. Okay, so what we want to do is we want to go through and find the cells that contain the people, and we want to turn those back on. So what... Okay, so... the question is, how do we go from cell to one of these terrain geometry objects? Because that's going to be the most bizarre part, is to find... Oof. Okay, first off, let's make this a little easier on ourselves. We've already got a bunch of kind of world things that help us keep the world organized. So you can see we've already got the settlement group node, which everything that, all the buildings, and that's pretty much all right now, just all the buildings. But all the buildings that belong to a settlement are subnodes, they're children, to this settlement group node. And I've got this tree super node that also, it's a kind of an organizer that hangs on to all my trees for me and puts them in a meaningful place. And we're just going to do the same thing with the terrain. I'm going to create a terrain super node. And inside the world generation, we're going to be appending everything to that instead of appending them to anywhere else. So when we say create the terrain geometry, we're going to go to our game world, and we are going to take this and say it's equal to a new node. And it's just a standard node. It doesn't have a type, it doesn't have a controller, it doesn't do anything. It doesn't do jack. All it does is look pretty and hold things for us. That's all we really want it to do as well. Also, we have to add it to the game world, because even though the game world is storing it right now, we want it to also not just store it, but we also want it to be a part of the world. Okay, so we create the supernode, we add it in, whoops, terrain supernode. We add it into the world so that it's actually recognized as part of the world, and then every time we would just normally add a new node to the world that is a part of our geometry, what we're going to do instead is we're going to use just this terrain supernode pointer. Append, there we go, append new subnode. Slightly different function, but it does the exact same thing in the end. And that's really all that matters for us. Also, let's kind of clean up the spacing of things. There we go. So this should allow us to quickly and easily dig through all the terrain. I don't know if I still want to really dig through all the terrain in this way. Or if I should be able to put a link between an actual cell and its developed geometry together. You know what? I'm gonna add... yeah, because terrain never really goes away. Right? We have no reason to ever remove terrain that I can think of. At least not without filling the gap in that we create. So... I kind of want to use a smart pointer just to make this a little cleaner and ensure that nothing stupid happens. But I also can't think of a good reason why I would ever delete anything. And using smart pointers takes up a little bit of extra space, and I don't really want to deal with that. So I'm just going to call this the cell mesh. Is this the right way to do this? You always got to ask yourself stuff like this as you code. It's really good if you get into a habit of, as you work, ask yourself if this is really the best solution you can come up with. Because sometimes you'll come up with a solution that might seem nice, and then if you sit back and stop for a moment, which I'm not doing right now, you'll notice, I'm still kind of coding away. But every once in a while, you kind of got to wonder if you're doing this right. I do need this to get nulled. There. I think this might be the best way to do it, though. This will give us a much cleaner look at how the world goes. At kind of the structure of the world. And it'll also allow us to bounce back and forth between cells that live in our kind of abstract idea of what the world should look like and the actual cells that exist in the game world. So, as a final step, each cell is going to have a mesh, which is, it's not actually a mesh, it's actually just a cell node. A cell, let's see, maybe I'll just call it the terrain node. That kind of seems like a better name. I like that. It's a little more descriptive of what this sucker is. There we go. And finally, your terrain node is going to be equal to this geometry object, which we have just generated. Good. Good. Yes. And once again, I'm going kind of fast, but I'm also kind of doing this on the fly. I'm amazed I'm moving as quickly as I currently am, because obviously there are going to be a few hiccups, and we're going to hit them like a brick wall. But for now, I'm able to kind of keep up a good workflow. And sometimes that is a blessing you just kind of run with. Okay, so we have our geometry nodes. Right, and the whole reason we're doing this little bit of fancy work, get terrain height. So once we have their position, once we have their XY position specifically, we need to do a few things. We need to grab the cell that they are currently a part of, which should be, let's see here. I'm trying to think if there's a better place to put this for now. And I might have to move this code in a little bit. But, we'll just kind of go with what we got now. So we'll call this the starting cell. And it's equal to the cell graph. What is that? The terrain cell graph? There we go. Get cell based on node position X and Y. So we're looking up what cell this person is standing within. And once we have the starting cell, we can then do a bunch of cutesy little things. For example, I notice I'm setting his X and Y, but not his Z. I wonder if that just kind of happens on a per frame basis. Node position.z. Let's just do it for starters, just because we have the information right now. We may as well. Seems bizarre not to. Oh no, here I am. Here I'm doing it. Ha! Okay. Well, if anything, we can save ourselves a little bit of extra computation by doing this. And now that we know what starting cell we're in, why did I care about this again? Right. See the hiccups in the brain? They're starting to kick in. We'll see how bad they get. This is our terrain node, and we are going to set... no. We need to get the object. Oh, and then we need to cast it to the right type, and ooh, there's a lot sitting in here. Okay, let's make that terrain node a little smarter, so we're not casting things all over the place. Generic geometry object. Nope, just generic geometry. It's not a member of C4. Really? Pretty sure it is. I love when the compiler says stupid things and you're just like, no, compiler, you're straight up wrong. Let me correct you by telling you the information I wasn't telling you before. Also, M comes before V. I like to have my pound includes in alpha order just so I can quickly and easily find them. There we go. It's a bit happier. I've still got some stuff I haven't quite finished here. We're going to set the geometry flags again. Oh boy. Okay. Starting cell. The terrain node. We could clean this up, but for now I just want to get it working. Okay, so this is the case where we need to remove a flag. And so in order to remove a flag, we essentially need to say we want everything but this one turned on unless it's already off. So I'm going to bring up MS Paint just to quickly kind of not completely alienate everybody who is just getting into programming or doing very basic stuff. So if we have our current geometry flags, and say it's, I need to make this longer, oh, no I don't. Let's say currently this is what it looks like. 1, 2, 3, 4, 5, 6, 7, 8, yeah, we'll make it 8 bits, why not? And say we want to, can I just move this sucker? Yeah, I can. Say we want to turn off, can I line it up? Not quite. I'm close to lining them up. There we go. And I hope you guys can see this. I know, actually, the text is bigger here than it is in my system. There we go. So say we want to turn off this third bit right here. The one I'm trying to kind of mouse over and failing. Let's see. Can I get brush, color, red? Yeah, so we want to get rid of this guy here. From the set here, where you can see it's clearly turned on. But we don't want to remove this guy on the right-hand side either. We don't need any kind of needless casualties, because that might break something else in our system. So what we're going to do, need to swap back, we are going to AND it against the opposite of what that flag is. So let's call that flag this, what is it? Key geometry invisible. Oh, come on. Don't do this to me. So what this means is now we're going to take this off flag that we want, and we're going to say, okay, we're going to do the opposite of it first. So first we have that, and then we are going to AND the bits that currently exist against this new flag that we've created, which is everything but the one flag we want off. And so what that will end up doing is it says, okay, the first digit, if you AND 0 and 1, that's 0. And then you AND that second bit, which is also 0 and 1. And now we're cute, because that third digit is 1 and 0, where it's on in our flags, but off in this new flag we've created, so that's also 0. And we go through and you'll actually see that it does this. It leaves out 1, 2, 3, 4, 5, 6, 7, 8. Yes, it leaves on the one bit we want to leave alone, but it does turn off the bit that we don't like. Kind of impromptu, what the heck does this mean? No, don't save it. Okay, geometry invisible. So we're turning off that one flag. That's all we're doing. That's what this kind of ugly mess right here stands for. We're taking what already exists when we get the geometry flags, and we are ANDing it with the inverse of this invisible flag. So this should make only the cells that they start on visible, which is what we've got, right? This is the known world for these guys. Granted, they can see trees, so they're actually able to very easily walk up, and you can see they're kind of getting caught on this edge. They're trying to go to this tree, but hand wavy. They'll get to it eventually. And when they cut it down, on they go to the next one. So the other thing we want to do, is close our documentation, because we don't need that anymore. And I think what I'm going to do is I'm going to take this code out of here. Yeah, no need for it here. Actually, there was a line in here that we did need. This one needs to stay behind. But these two can come with. And this is kind of an oopsie. We can just set that back, say get terrain height. Sorry, don't worry about this. We'll put it back. Alright. So there's our position. And then we do all the other stuff that we don't care about a ton. And we don't need the extra white space. Okay. So where should this code go? Probably it should go into this villager controller somewhere. And for now we're just going to do the ugliest thing possible, which is, let's see, if you're not asleep, we are going to find, ooh, okay. Yeah, this will be a good spot for it. And I'm just going to put it here for now. It might not be its final resting place, but you never know. It might be as well. Yeah, there we go. And we should be able to get our own position, right? I'm actually just going to say position. Get world position. Oh, whoops, we need to get the target node to know its world position. And it's easy enough for us to just say, okay, here's your X, here's your Y. Good luck, have fun, don't die. That actually rhymed really well. And if you guys have any questions, feel free. I know I'm shooting through this real quick, but I'm trying to I'm trying to make a point of just how easy this actually is. At least for right now. We're going to get the cell, and then we are going to accidentally highlight way too much stuff. Yeah, no. We just want the terrain node. Doing a little cleanup. If we do the swap here, where before we were storing the actual cell in this pointer, if we instead swap out the cell for the terrain node, you'll notice we only do one dereference right here, and that keeps us from doing two dereferences later. In fact, if we wanted to, we could even go so far as to do one more dereference, and I keep changing the name to kind of reflect what it holds, but each time we can kind of go another step, and that step saves us 2 steps later on. And it also kind of cleans up our code a little bit. If you look at this, you go, okay, the game world, we get the cell graph, and then we get the cell's terrain nodes object, and store it here, and then we do the set flags, all right here, in one shorter line. It kind of gives us a better idea of what's going on. Thank you, WoWFreak. That was a very well done response. I give you 8 for 8, mate, for this rhyme. Okay, so this should... It's a little overkill. You'll notice it's happening every single frame. This is getting run. As long as they are not asleep, it's happening. It's a little overkill. But I'm not too worried about it being overkill. Ooh, I have a heck of a splinter. Sorry, that was painful. So this is happening every frame. We would eventually like it to only happen when you change from one cell to another. Is just check, hey, is it on? Okay, no, turn it on. Aside from that, though, we're not too worried about it, because that's not a lot of processing going on in there. And it's not like the new cells turn on too often. So here you can see the trees are kind of falling and collapsing, and I'm going to just set down a settlement object here so that somebody can build it. And you can see as these guys head out to get to this set of trees, that they're illuminating everything they cross on their way. So they're actually going to walk over this blank bit, maybe? Oh, maybe. That's going to be close, but it might illuminate this edge as well. Yeah, there they go. They step onto it, and there it is. So that's kind of cool. We're starting to get our first look at what is going to just kind of exist inside of this Fog of War system. Get the first bits and pieces of it in place so that we can not have to dive on it all at once. Whew. Okay. So is this everything we want it to be? Because for now it kind of looks like it is. Granted, we're not turning off trees. That might be a bit much to ask right now. I do like how each time you see them go a little further to get trees, though, they are continually exploring more space, and what is known is becoming more apparent. Also, they're collecting a lot of wood really quickly. We're almost already at the 200 mark. I didn't actually expect them to be able to collect wood this fast. I might have to turn that down or figure something else out, because they will very, very quickly deforest this entire area. Not the end of the world. That might be a gameplay thing, is early on it's very easy to stockpile and get a ton of wood, and then as the game goes on you kind of go, oh crap, I have to start going really far to cut down more trees. Suddenly it becomes more dangerous. That risk is going to start going upwards. And that might be part of the design. I might actually like it like that. Kind of looking at my to-do list of what I plan to do, and it's like, okay, well, I've done most of what I plan to do. I kind of wonder if I could fit getting trees in or not. I'm kind of afraid that that'll turn into a nightmare, but let's see. Also, my phone keeps going off. I have no idea why. Oh, people following me on Twitch. I know I don't normally do this, but Salter HD, thanks for following. I'm glad everybody who hits that follow button will be able to join me in the future. This is a relatively quieter stream. Music's going, people aren't talking much. Oh, sorry. Bossinator asks, have you tried the Qt Creator IDE? No. I'm pretty boring when it comes to my IDE decisions. For now, I kind of keep with what works. And especially, I tend to keep with what I'm more familiar with, because if you change your tools too often, it tends to become very difficult to understand where things are and to find all those neat little features that really speed up your programming. So for now, I'm going to keep I tend to keep with what I've got. Eventually, I definitely would like to look around and see if I can do better in terms of IDE. But also, not only do I use Visual Studio here, I use it at work. So it makes it kind of easy to transition between, you know, I got off work only a couple hours ago. And so it makes it nice and easy to go, okay, climb off the work laptop, drive home, take the dog to the park for a little, and then hop on stream and just be focused and ready to go instead of having to completely change your mental gears. So how do we turn these trees off? Because turning them all off is easy enough, right? We just go back where we generate them. Where are they? These trees, yeah. I wonder if I can just turn off the group node. Let's try that first, because that would be not just cute, but kind of a good thing to know. Let's see here. I want not the tree super node, but the cell tree group node. There we are. Cell tree group node. Can I just disable it? I would laugh if this is all it takes to just turn off every tree, and then just to re-enable them to turn them all back on. Okay, no. It does not. In fact, it doesn't look like it's doing much of anything. So, as it turns out, disabling a node, I don't think disables everything below it. Let's actually disable. Node disable, specifically. Just look at the code, see what it does. So it adds a flag that says that it's disabled. Oh, and then it does go through every single subnode. That's interesting. I have a feeling, though, that there isn't a quick and easy way. Let's see here. K node disable. Let's look at those nodes that, or the flags specifically that we saw them turning on and off. Non-persistent, disabled, animate, inhibit, unshared object. Direct enable only, that's interesting, but not interesting enough. Pre-initialized, instance hidden. Ooh, that might be nice. K-node instance hidden. That might be what we're hunting for here. Unfortunately, it looks like the hidden is only something that exists within the editor, not something that exists within the game. So that's not really what we're hunting for either. This node is disabled. Man, I wish that just kind of turned everything off. That would have been nice. But alas, alack, we just have to turn all the trees off. It's pretty much what we gotta do. So each time we create a tree, we don't just sleep it, we take that tree model. Let's see, we have to grab the object. I have to be able to type get object first. Get modified flag. No, that's a Boolean. Okay. Actually, what kind of object do you even return? The most generic thing ever. Fair enough. Huh. I don't actually know how to hide this darn thing. See, I told you I'd hit a brick wall at some point. I just didn't think I'd do it on such a simple task.
Listen, all this takes a lot of getting used to. And you do get used to it. After a while.
Alright.
There's 3 things I'll always miss, though.
Come on, Node.
1,
Tell me something I didn't know.
not having to watch my step all the time. 2, forget about 2. And 3, I miss the songs. Folks from Ceylondia knew how to carry a tune. Sure, we've got some songs on the old gramophone, but try and imagine what they sounded like, playing to a room full of fine people, unwinding at the soul regret after a hard day's work.
Ah, found it.
Those were the days.
Okay, so we just have to turn off its perspective exclusion mask, which essentially says if it matches the camera, I'm just going to set that over here, if it matches the camera type, then it's not included in there. So we just say, oh, well, don't include it for this one type of camera, which happens to be the main camera we look at everything with, and that should turn it off. So we tree model, we get, where was that? Okay, we just set node perspective, what? It should be here, right? Oh, whoop, just set perspective. Exclusion mask. And then we turn it on for this one, and this should hide all of our trees from us. Yeah, okay, no more trees. Fantastic. And you can see they have shadows, right? Some of these, here are the shadows. They exist. Okay. This becomes a little bit difficult. I'm trying to kind of wrap my head around an easy way to turn them back on the same way we are cells. And I don't want to do it every frame, but at the same time, it might be the only way. At least for now, until I have something simpler. Cell geometry. I don't like doing things every frame. I really don't. Well, okay, for now we're just going to do this the lazy way. We'll clean it up and fix it if we decide that, you know, This is a place that we could be doing better. Because once again, we have to build a game before we can get a game running well. It's not a game if we just sit here and optimize all day. So let's get a game. Let's make a game. So we're gonna find if actually we do this every frame. We already know what's going on here. Okay, so we need to do one thing first, and it is we need to back off of this object a little bit. So we're gonna undo some of our steps we had before. There we go. And we're gonna use our cell geometry to find essentially the closest tree node. In fact, this is something that probably should exist in the world, if it doesn't already. Ah, I have a find nearest tree. So let's just broaden that a little. Find nearest tree group. I love it when I write myself little functions like this that kind of already do most of what I want. And we just have to do a little work to adapt it to do the rest. And you'll see I'm completely overzealous with these const keywords, because this essentially allows the compiler to do cute little things that make our game go even faster, because it allows the compiler to essentially make assumptions that it wouldn't be able to make before. Whee! I have some Smarties left over from Halloween. Getting rid of the sugar now so I can keep going at full speed. Maybe that's why I'm doing so well. I just need to feed myself sugar the whole time I program. I mean, I feed myself coffee. So let's just take the code that already exists and use that. Ta-da! And since we don't want to just copy and paste code and not make use of neat little functions we've written for ourselves, let's actually go so far as to even say the cell node is now, we're using our own find nearest tree group to the point. And now we don't need some of this like other stuff in here. In fact, that makes our code cleaner without expanding it too much. Hopefully that didn't break everything. I guess we'll find out in a little bit, won't we? So we have right, I remember. So we're hunting for a tree group. So just getting the nearest one. Okay, well, let's get the nearest one first. So we're going to find the nearest tree group. Not just the nearest tree, but the nearest tree group. To not us, because if we find the nearest one to where we're standing... Actually... No, if we find the nearest one to where we're standing, that might not be the most accurate thing in the world. So what I'm going to do instead is I'm actually going to get the cell's position. There we go. Okay, so now we've got our tree group. So we know it's the nearest one, but we don't know if it's the right one. So what we need to do is essentially say... Actually, no. The tree groups... See, this is where that organizational stuff I was doing earlier kicks in. I can say if the squared magnitude of the distance between the tree group and the cell geometry So if this distance is less than... we gotta make this somewhat stupidly small, don't we? Let's try like 100th. Let's see, 10th, 100th, 1000th? Let's try 1000th. We say if these two are essentially on top of one another, we're giving it a little wiggle room, but not much because we're using the squared magnitude. And we're saying if the distance is less than this, then we are going to go through every tree, or I guess I should say just every node, but we can kind of assume every node in this group is a tree. Get first subnode. There we go. And we say while the tree isn't a null pointer, tree equals tree group, get next level node tree. There we go. Tree, set perspective exclusion masks to 0. Ta-da! So the one thing you will notice is that the AI will still know where things are. Even though I'm hiding the information from the player, the AI still has perfect information of what the world looks like, because I'm not limiting its access in any way to what may or may not exist. I'm only changing what the camera sees. So this is kind of something that, unless you really, really work hard to make sure that the AI can only see or not see certain things, it's going to continue to be smart enough to put down, you know, all of the things in the right place. It's going to know where all the trees are, despite the fact that we as a player can't see them. Like, as a player, I can assume that right here, you can see how the shadow is getting longer, that there's a cliff that goes upwards right here. And we'll discover it eventually. But it's something that you can't currently see that will pop in after a moment. Anyway. So this is all I had hoped to accomplish today, and I've got other stuff I need and would like to get done anyway. So I'll leave this running, take questions, and, you know, I'll talk a little bit more before I sign off. But, you know, thanks guys in advance for stopping by, watching me do little things today, and we still accomplished something significant. Might not be as significant as some of the other gameplay features we've implemented so far, but it's still somewhat significant. It's still something that kind of shows progress and is working towards the final goal. And, you know, if you're here for the first time, welcome. I'm making a kind of a real-time strategy hybrid with survival and kind of city simulator stuff. I'm kind of very early in development, so there's not exactly anything to do other than play with it. It's a toy currently in the definition of toys and games. It is a toy. There is no conflict. There's nothing trying to kill you yet. I say yet because eventually. So yeah, if you guys have any questions, feel free. Otherwise, thanks again. If you're here for the first time also, and you want to see more of me programming, there's a fantastic little follow button below me, and you will be notified every time I go online. And you can watch me plug away at C++, you can ask me questions, probe into why I became a game designer, or why I want to do all that stuff. But it's been a nice quiet day. And you guys seem to be nice and quiet as well. So thanks again for joining me. I'm gonna sign off. Later.